Okay, so it's probably started. Hello guys, I'm glad to see you again here. The topic for today's light talk is clean code. It's a pretty important topic because you want to write better code for everyone to understand it. And today's speaker is Filip Stankiewicz, a really experienced TPAM tutor. I think he was teaching people Java when I just started learning it. So, Filip, you can go on.
Okay, thank you, Danila. So today we will touch number of topics. Feel free to ask questions if you have some during my presentation. Feel free to interrupt, and you also will have time for questions at the end, I think. So, and I would like to start from my question to you. So, what do you think? What is the main goal of developer? Who can answer this? Who can try to answer this question?
Maybe to solve real problems.
Good try. Yeah, but I'm thinking a bit like from I would say what is the difference between like a professional developer and like self-learned developer, or I mean, what like differ like professional from anyone else, and like if we think about this perspective, what do you think is main goal of developer? Any other tries?
But self-learned developer also can be professional.
Yes, you're right. But I mean, there could be two developers that can solve the problem, but one of them like will be more. I mean, will follow this goal, and we will be professional. But if you like and do it like not following the idea what I wanted to say, you could not be considered as a professional. I mean, let's say, what is the main goal of like professional developer? Any other tries from anyone else? Don't be shy. I gave a hint to you. Okay, if no one wants to answer, I can try answer myself what I mean. So yes, you can solve tasks like and like the program will work and perform the main like function, but it is important not only to solve the task, but it is important the way you solve the problem. And here on the picture, I would like to explain that it is important that like everything we produce, we can maintain, like fix, change, and so on and so forth. If like something you produce is not possible to maintain, to fix the car, for example, probably no one need such a car. So the same thing with your code you produce. It should be maintainable it means like first attribute is readable, but not only readable, you should have ability to easily change your code without like any difficulties. So you can, I mean, like new developers or not experienced developers or like someone who tries to do something on his own first, usually you can solve the problem, but it will be hard to like extend your solution to to understand other guys your code and so on and so forth. So by learning development, by learning how to write the code, we should not only learn the syntax, the like tools, but we should learn also, and in my view, it's most important and most like complicated thing, that you write your code in a maintainable way. And I will explain you today how to do that. So here on the slide, you can see like dependency, number of defects found in the code, and time. So like usually no one needs the program that is not able to evolve, meaning development cost of a software is very, very, very high. So if like 50 people works 3 years on your program, it's cost lots of money. And you don't want to like write it once, and you like if your requirements, business requirements changes over the time, you want to make changes into the code and fix like issues with your code. But if your code is not really maintainable, fixing one issue can introduce like two other issue. And on the slide you see this point in time. It's this point in time means that it's no longer feasible to maintain your program anymore, because when you change something you break like twice more or 3 times more and so on. So every program eventually will lead to this stage. But the goal of the developer is to reach this point as late as possible. So it could be like 10 or 20 years in ideal case, but if you write your code like not very nice, it could be like several months. So, and you need to rewrite everything if you like have like significant changes in your requirements and so on. So, and we will learn how to do that, how to write code that like everyone likes, I would say. But no one, everyone do mistakes, and we sometimes it's not possible to like predict mistakes, and eventually every software has mistakes. But it's not a problem. We learn from our experience. And on this picture, you see the bridge. First, when engineers started to build bridges, they was not aware of aerodynamics, that it plays an important role on the construction. So, and due to aerodynamics, this bridge was like broken. So we didn't have enough knowledge to remediate this failure. So, but it's okay, it happens, but we need to learn from that. And if we like write maintainable code, if we like use the approaches practices to write a good code, so there is like less probability that we introduce like a defect in your code. So and the earlier, I wanted to say that there is always will be defects. And it's not a problem. It's not possible to not to introduce them. We just need to understand how to reduce the number of defects, how to deal with them, and how to find them earlier. So, and there is graphs. So if you like introduce a defect on the, so probably you should know that building a software consists of a number of stages. It's like requirement definition, architecture of your making architecture, like of your software architecture, meaning like how your components will be interconnected, which part of the system you will have, and so on. And like finally, construction is the stage where developers work, they write the code. So if you introduce a defect or an issue like in an earlier stage, and the later you find that the more money it will cost to fix this defect. So if you introduce it in requirements and you find it in the next stage, it's still like not a problem in terms of cost to fix it, but if you find issue in requirements after release, it will grow significantly. So the earlier we find defect, the less it will cost us to fix. So if we write a good code, a maintainable, a readable, understandable code, there is less risk to introduce a defect. So it's less risk for business and less risk to lose your money, business money. So, and the question is how we can write a maintainable code. So we programming started like early 50s, like past century, and there was no clear understanding how to write a good code, and then people started to think about how to write a better code that has less errors and so on, that it is less error prone. And there was some evolutions like this machine and assembly languages are not really high level languages, very low level language, but people then start to introduce more abstractions, so they can easily write the code, and they started to introduce some paradigm to make your code more maintainable. So first paradigm was procedural programming, then object-oriented, and later came functional programming. So here you can see that procedural programming appeared in 70s, OP appeared in 80s, and in 90s appeared functional programming. So let's talk about this paradigm from the beginning. I will start from structural programming. That's kind of approach you used for procedural programming as well. So the idea is to design your program, to build your program using top-down approach or bottom-up approach, and to decompose your code into components and use flow control structures, and don't use go to operations, which completely mess your code that becomes unmaintainable. And this construction was used sometimes like in high-level languages, but now it's no longer used. So what is the idea? There is typical flow control structures that you need you can use in your program to support this idea. So all modern languages have this structures. So you write your code sequentially. You use if else operators to like make decision. You use loops, and you call method and make a return. So that's all built in modern languages, but people came to this not from the beginnings. They use some go-to operations and so on and so forth. So if you use this construction, you will be safe. So what else? Top-down approach. It's how you decompose your program. So you should not write all your program in one main method. So you should not write 1,000 lines in one method. Because it's not easy to understand at first glance what your program is about, what is program you're doing, and so on and so forth. And you may say that I can document it, meaning you can write comments, but if you write your code in the right way, it's usually self-documented and it's not required any comments. So let me explain how you can decompose your program. Instead of writing all codes here in main, you think which parts your program has, and you can simply write a pseudocode or comments. So what your program what steps, which logical steps your program has. For example, I read data first, I do some calculations on this data, and then I show a result. So, okay, I made this. What I do next? I translate this pseudocode to functions call. Instead of writing all code here, I write a function that will be reading my data. Then I have in this data call the other function that do some calculation on my data, and then I call the other functions that print the result. So and now my main program, my entry point of my program is short, concise, self-documented, readable, understandable, many attributes. And I can easily understand what this program is doing without any comments, without any documentation. So it's called decomposition. I decomposed my large problem into 3 smaller problems. Okay, and then I connected these 3 parts. So and these methods can be quite complicated. And I can follow the same logic when I write in this method. I can decompose this method also onto several parts. So then I try to write this method. So my read argument method will look like this. I create scanner, do something else, request line, and return. So when I look here, if I need details, I go to this method and understand. But this method could be longer, for example, or it could be also decomposed. Then I implement other parts, which is calculate factorial. I do it a known way, and then I implement other function. You may say that it is simple, why I need method for one line, but it's not always one line. Could be tomorrow, it could be extended to 3 lines, 5 lines, and so on. So it's good that we have like these methods like independent. They exchange the data by passing and returning an argument, and I can call this program maintainable. So if I need to change like how I print the result, I go here and change it. So it's called top-down approach. And I recommend it to everyone before you start writing the program. Try to like save the code at first, like and then convert into smaller problems. So it was structural programming and top-down approach. So if we go further, the idea, the next idea was object-oriented programming that people invented. So, and this approach of decomposition was not enough program. If program was too big, they was still like complicated and it was not easy to maintain. And people introduced couple of things, and probably most important of them is an abstraction. So instead of like doing method calls, we introduce like some abstractions. For example, if usually like program operate with something that has like they reflect probably like real life object or like and operate like with some objects that's so more or less close to real life. And we can describe these objects like in form of abstraction. Abstractions means you have a real object and you just identify the main attributes of this abstraction that you are concerned about. So you don't need other attributes, you only need like several attributes, and it just simplify your like representation of your real object. And it was like a most important like thing that people introduced. And how it looks like in the code. So like class, it's like an abstraction, and using like class paradigm, you can describe an abstraction. So if we like take into account the house that you saw on the previous slide, we say, I have an abstraction that is house, and I'm interested only in 3 attributes, which is length, width, and height. So don't forget about now this privates and so on. Just I have integer length, width, and height. So I somehow pass this data to this abstraction and save it inside this abstraction. And I have some functions or methods, as they call that can like give me some value from this abstraction. So we can get square, for example, of the house, and we can get perimeter of the house. So, and having this abstraction like simplify your code much, and you can pass this abstraction between your functions and so on and so forth. So it will significantly simplify your code. So going further, the other like improvements was introduced after object-oriented like paradigm. It was like design patterns or principles, which example of them could be like separation of concerns, low coupling, high cohesion, and so on and so forth. It means that we have some rules how we organize our abstractions, and we put some limitations on how they interact between each other. So it's basically called architecture. So, and this also help to reduce uncertainty of your code, and it's easily to maintain, because we like having a package of abstraction. I would say we can like plug in, plug out this package, and we can replace this package, and so on, so forth. That's why like your system is like composed of like smaller parts. So it just for introduction. Don't worry if it sounds complicated for now. You will understand this later, but it's just for introduction. So, and going further, after design patterns or in line with design patterns, we also follow some best practices that make your code more maintainable and allows you to like detect defects in your code as early as possible. So this paradigm, this approach is called like test-driven development, or for now we just call it unit testing, or just simply testing, right? And then it's continuous integration when you try to build your program from the parts and run it. So if something goes wrong, you will see it like on earlier stages. And the other also important paradigm, probably it even goes first, called code review, when your code is reviewed by other developers. When you write a code and your colleague like going through your code, and if he doesn't understand something, he's saying, here I don't understand something, probably we need some improvements in the code. So that's why you getting feedback, and you have other couple of eyes looking your code, and if you like didn't think about something, you like introduced a hidden defect, so it can be seen and found earlier. So there are techniques or best practices that help us also to develop a better code. So going back like to, so now we will be more specific and also talk about what exactly we can do now to make our code more maintainable. We can follow code convention. What does it mean? Code convention allow you to write maintainable code and improve readability of your software. So one example of code convention is like you should name your variables in following specific guidelines, meaning your variables should be named like meaningfully, like it should have like understandable, readable name, and it should like bring some value of what your variable means, and so on and so forth. You could not call this variable like string or str, because it means nothing. Because okay, string, but string is just type, it's already written here. But if you say it's username, it gives some meaning of your like value of the variable. So probably first number is even not the best name. We can call it like P number and call it like 3.14. Okay. Instead of having just number 1 or whatever. So, and not only like a name should be meaningful, but you should write it in a very specific way. You should use like lower case at the beginning, and the next word goes with capital case, and you join the words with no space. you could not write like this. And you could not start the word from like capital case. Generally, you should try to avoid of because it makes your name longer. But if you can reverse it, it will be like better. You should name your like constants, the values that not change, like class level constants. You should call name it with capital case and underline. So it's quite different from that. So it's class level constants, and it's like a method or function variable. So you may ask me why I should follow this guideline, why I could not do like this. I will explain. Let's imagine situation when you go to supermarket and you know where your favorite meal is located. You know you need to turn right and turn left, and on the third shelf your milk will be like stored. And you go to the supermarket like every day, grab your milk, grab bread, and you know where to go. But let's imagine like every day they change everything. So today milk located is here, and other day milk located in the other corner of the supermarket, and you need to spend like 20 minutes going through the supermarket to find your milk where you buy every day. So it's probably not pleasant experience, and some of you may experienced this in past. So sometimes like guys in supermarkets change something, and you'll just having troubles to find something. So the same with the code. Like if every developer will follow his own naming guidelines, you will have the same problem. You will spend like 20 minutes more in order to understand what naming guidelines this developer is using. But it will cost money because your time is money. So if you like follow different guidelines and you work as a team, it will be like hell to maintain this code. So follow guidelines. It's very important. It's the smallest thing you can do to improve your readability. It's must to have. And like sometimes you maybe like when someone like check your code, he always be like paying attention to this naming, so on, to the style, and you will be wondering why I did the program right, everything worked correctly, but why I got like low mark, because my variables like has like underline instead of no space. Yes, because it's very important. It's like your code is what you do, and should you do you should do it carefully. Okay, let's talk about other. Since we don't have much time, I will speed up a bit. So methods should be also named with lowercase in Java, pretty the same, but they should be verbs. So your method should be a verb. It should not be a noun. Your interface should be a noun or like an adjective, usually ending with like clonable or something like this, like an attribute of something, a characteristic. And your classes are named with capital case. So like everything else, but start from capital. Okay, you should not start from smaller case and so on and so forth. I would not stop it. Let's go further. Avoid using magic numbers inside the code. Use constant instead, constant values, class level constant, and name them accordingly. It will help you to document your code instead of writing comments, like name it. Formatting. Formatting is also very important for the same reason I mentioned above. So put curly braces on the same line with operator. Don't do it other way. Don't overuse many dots in one string. Try to introduce variables because it will provide like more information to your code. There could be exception to this rule, like lambda functions, but we don't go there. But for now, like follow this guideline and like don't do like this, like define your variable before you use it and try to have less lines before the definition of variable and usage of the variable. Okay, don't do two nested methods like if. So try to not exceed 3 level of nesting, and 5 is max. So you may ask me how to reduce, like you can extract it into a method. That's how you can reduce your nesting level. So there is also some techniques how to reduce nesting. You can use like guard clauses. So instead of having like this, you may put like this. But also be mindful, put these guard clauses only in the beginning of your method. Don't do like exit like in between your method, because it's also violates structural programming principle. Properly, I will explain it a bit later. Yes, so you can extract methods. So print banner, print details, and print. Instead of having a comment, you can extract this into method, and instead of this, you just reduce the number of lines in your method. This method is became like more readable by introducing other method. So also don't write long methods. So your method should fit into your screen. Like ideally it should be like around 10 or 20 lines, maximum I would say 50 lines. Basically it's all written here. And the last point I have for today is about testing. It's you should not only test your program with your hands, you should write some code to test your program to understand that it works as expected. And as I said, we all human, we all do mistakes, and we may think that it's written completely 100% correct. But in fact, to make sure that it is correct, you need to check it. And when you're writing something that checks that your code is correct, you finding more mistakes, and this test can be reusable later. Yes, it usually happens as I explained. And there are some tools. I'm not asking you to do that now. It's your very first program, but I just want to introduce an idea of unit testing, and that you might find it useful for later. And just be aware that it's also a technique to reduce the errors on your code. Your test look like as a code that checks the functionality of your classes of your code. So for example, you wrote an abstraction calculator, you create this abstraction, you call the method of your class, and you check that actual result that you was calculated by your code is equal to expected result. And if you if it is equal, your test will be green, it is passed. But if it is not equal, if you did a mistake inside, so it will be red, and while compilation time value, when you compile your program, you will see that something is wrong. Or for example, it's if someone later introduced changes into your calculator and these changes break some logic, you will see also as early as possible, because when you compile, your test will be failed. And there are some rules when you write a unit test. They should be fast, independent, repeatable, meaning they should bring the same result when you repeat, self-validate, and should be took less time to execute. They should be, fast, and you should write them actually when you need them to. So you need to write them after or before even you wrote the code, not like several months after, when a defect is found in production and so on. That's probably it. We even fit into our time frame. And then on the next class, we will talk about object-oriented paradigm more. And we will talk about abstractions, object classes, and so on. So, time of questions now. I guess you should have some. What is not clear for you? Do you agree with my ideas, or maybe you have different thoughts?
If I may interrupt a bit, I totally agree with your thoughts. I understand them. I just wanted to say that our students are probably already familiar with unit tests, and maybe they don't know yet, but AutoCode works with them. So you write your program and AutoCode executes unit tests that were written previously. So later you will write these tests yourself too.
Yeah, you're right. Any other comments from anyone? Any questions? Usually, if you have no questions, it means everything is understandable or nothing is understandable. Okay. Okay, yeah, you can rewatch the video anytime later when you need it, if anything if something is not clear to you. So if no questions, we can probably call it a meeting and stop the recording.